All right. Well, thank you so much, everybody, for joining us today again. The date is July 23rd. And initially, we had on the agenda today to talk about OpenVLA, 5.3 Vision, and Carrie was going to present on some great stuff that they did with Gappy and GenRunner. However, overnight, to much anticipation, Llama 3.1 was released along with some other mono releases too that came out, like this Nvidia Minitron SLM. But yeah, obviously big in the news. And people, I believe, someone had seen this coming. Zuckerberg had been tweeting about the big 405B version going to be coming out of this. Notably, it does support tool calling and function calling in it. I've not messed around with that yet or dug into the templating because I've been working on the OpenVLA like 24 hours a day. But I did test that this will still run with its 128K context length. It runs through like MLC and Llama C++ and all that stuff just the same at the same expected performance. Obviously, when you get up to the long context of this, it does start to dip off like a few percent in terms of like token per second throughput. But otherwise, it seems like a good model. I've not really had time to play around with it yet. I think I'm still personally waiting on access to like the public version of it. They had sent us like a thing to test a few days ago, just to make sure that it runs. But I don't think the weights were the final ones. But yeah. Wait, they did grant me access to it already. See, they're equipped with this. So even if you don't want to run this right now, go in here now and request it so that when you actually do want to download, you don't have to wait for. I assume it's like they probably have Llama approving everybody on here. But yeah, if we go into the config, let's check this out. So it's still with the 128K tokenizer from Llama 3, but we see here now the context length is a full 128K, which is great because this was becoming an issue with the tool calling, adding like thousands of tokens to the system prompt and stuff. So and that was a real common concern that was coming up in this open source model community that, hey, all of the long context models are being held back, and we really need that to move forward. So it is good to see that these are more coming out, and of course like Meta and the Llama team come through there. I'm trying to see real quick here what its performance is on the function calling. I think this is related, but yeah, we'll dig in when I get a chance and look at the templating for this. Okay, this is what I was looking for here. What does the template for the function calls do? And this is awesome. I think this is one of the first like major model releases that has this tool tuned capability built into it. JSON function calling. Like I did not get the template a few days ago. Okay, this is what we're looking for here. Okay, so it looks like you embed the tools here, the descriptions. But where is the actual? Okay, it is interesting. They do it a little differently than. Yeah, see that is the thing about supporting these different tool calling models. The few that I've had working so far, they've all required some like custom templating of how they all define it. Okay, this is the tool descriptions. This is what I was looking for, and this is the same descriptor schema as the OpenAI Pythonic one. Yeah. Okay. We'll have to give this a try soon. You can see, like, digging into this, you do really need to go through and make sure all the templates are lined up and everything. That's the tricky part. But I would assume that this would like take over. I know like we've been using that news from Mes model for a while, which was like really great to actually try these things in practice and get to using it. But I assume if like the base model Llama version does it from here on out, this will become like the de facto standard for doing this, which is really awesome. Okay. We'll try integrating this and getting it all into the stack. But at least it runs, quantizes, and gets like the normal 40-ish tokens per second of performance that you can go and start messing with. Then Nvidia also released this Minitron SLM, which comes in 4B and 8B variants. There's actually a cool paper on it here. And I've been working with this team for like a few months now on adding different capabilities into this. So like Nvidia learning to train and distill our own SLMs, which should very nicely couple with the VLA mini VLMs that we're pointing at, that we've been using a lot. And this seems to have been getting good reception so far on in these different model communities and stuff. I think they only released the they only released the base versions of these so far. But we will release the instruct ones, I think, next month at some point. At which point, you know, having this on the Over Nano alongside the mini VLA model and like your ASR and TTS stuff, then it all becomes quite more realistic to fit it in there. As we can see, this is a smaller 4B version. I had tested the performance of this too some weeks ago and recall it being in like the 70 to 100 token per second range on JETSON AGXO, and similar in line to like the other SLM benchmarks that we already have for these other ones. The difference being like this Nemotron is trained on commercially available data, and you know you'll be able to use it in actual products and stuff. So you should desire here. I can put a link to this in the chat. And if anybody has any questions at any time, you want to hop in and talk about things, feel free to. Oh, Nigel, I see your message about the build.nvidia site. I'm guessing we probably already have demo endpoints up to try this stuff.
Pretty nice to just hop on for free and try them out.
It is. I know. Like I've been getting pings all morning from like their War Room Slack channel. They've been like awake like since ungodly early to get all this stuff ready at like day 0. Bless their hearts. They get all this going so people can hop on and try basically instantly without having to download a 768 gigabyte model file, which I've been reading just about like the size of these, and it is kind of wild. Let's see if it works. It was so fast I didn't even. Holy smokes! Is it? And this is the 480, 405. Okay, maybe you did pre-cache that. Oh, all right. It did the function calling. Nice. Okay, cool. Well, I do like how they've laid this out, and like you have to give your permission for it to like run the tool and stuff. For a 405B. I'm assuming other people are hitting this endpoint right now too. That seemed to be not too bad of latency for right out of the box. I'm sure they're trying to optimize it for like FP8 and stuff, but that's cool. It already does the tool calling. So yeah, I'll have to really the tool calling templates I have to go through like line by line. It's not dissimilar verification to like the OpenVLA stuff that I've been working through. It's just like you really need to make sure everything is buttoned up with it in order for it to work. Ideally, it would be nice if these models started to kind of converge on how they do the tool calling in their chat templates, because it does get a lot to continually support and test all of them, that it still is doing the function calling and you're giving it the correct input schemas and all of that across all of these like tools that you have. But yeah, I think mainly people are really excited about this 128K context length on it. And in general, though, if you think about like the Llama models are basically the base of our stack. Well, at the bottom, you have like the tokenizers and all of that. On top is built the LLM, and then from there, there's the VLM, and now there's a VLA on top of that. But if you look at like the pace at which these the base LLMs keep coming out and have great enhancements in them, it does become an issue to like keep up with the latest. Like for example, with the OpenVLA guys, they had to not only get, I think they're still on Llama 2 with it, but theirs was trained on top of the Prismatic VLM, which that took, months to do. And then their work took months to do also. So the longer term strategy of like, how do you constantly keep up with all of these enhancements in the base models? Because we would like to get function calling in the VLMs themselves too. Because to date, like in the one previous demo that I showed it, I had the News from Ed's 8B model function calling based on VLA's output. Well, the VLM should just be able to do function calling too. It's just like when they get trained, they're only trained on image captioning, so they like lose all ability to chat essentially. And in the future, we try to like retain some of that. So then the VLM could just call the functions directly, or whatever constrained JSON output or the grammars that Nigel had so kindly given us that helpful tutorial on last time. Basically the same thing or effect in practice of getting that. But considering our applications are like embedded systems and physical AI, as it's referred to now, that is all crucially important for us. Okay, we can circle back to these a little later. I know that like Llama 3 release was huge when it happened, and 3.1 it does seem like it has actual substantial feature improvements in it, but also like people get tired and having like just the onslaught never stops coming, does it? Okay, so I wanted to cover the latest progress that we've been working on with the OpenVLA. Nigel, myself, a couple other guys here have been going on this pretty hard. Okay, before Chris, you had your hand up. I'm sorry, I didn't see the window here.
That's all right. I had a quick question. I noticed reading the release notes on the Llama 3.1 release that they say that running the function calls through 8B is unreliable, and that you have to run. And that you have to run the 70B model. How small can you get the 70B model, and is that going to fit on a JETSON?
I did not read that part. Okay, and the good news is the 70B will run. Okay, and I have a video out of talking with Llama 2 70B on HEXORun at 5 tokens a second. It turns out that 5 is just threshold of verbal rate. Okay.
Okay.
And
Yeah.
I remember like eking out every 0.1 token per second out of that demo just to like get it fast enough. There are people that do actually use 7dB on OREN. Many of them are doing like higher order agent stuff and are fine waiting a lot. It is not necessarily for embedded that they're using it for. I forget, there's this like coding agent, Dylan, or I forget right now, but you like give it a hard problem and it'll go off and take a few hours and like recursively solve these challenging coding issues that you give to it. And those type of folks like to use the 7dB. But practical terms, no, it takes up 35 gigs of RAM. And it runs and everything, and I do test it now and then.
Even
but
quantized, you're not getting it smaller than 35
yes,
gigs.
you will only, and that's 4-bit, okay? Because of 4-bit
I
to
got
get the memory, you divide by 2, okay?
Gotcha.
So
Gotcha.
even 8-bit isn't happening either. So that is interesting in the that must be somewhere else. You said in the release notes it says that. Can you
Yeah,
put
so
a
I was
link in the
reading-
chat?
Yeah, I'll send it to you. It is right here.
Oh, Randy said he was able to run it through MLC too. Okay, good. That's good to know, Randy. And we do try to make this stuff as
I just sent it to you in the
reliable
link.
as possible.
You can find it there.
Okay. Here, let's pull it up for everybody. And then I appreciate okay, these models all just came out this morning. We're all like swarming on this to see what they can do, because it like translates to real capabilities for us, what we're able to do. And okay, this is on their website. Yeah. These guys are great, man. I appreciate so much what.
Yeah, I mean, there was a lot of information here, and it's right there as the lead story is that 8B is not reliable with the tool calling.
Okay, all right.
It can't. Apparently, it can't carry the conversation at the same time.
Okay. So it's kind of similar to the VLM, and like that overrides all previous directives that it had. And also, like that news from Hermes model has served us well for some months, and like we're not going to be quick to ditch it just because new Llama came out or whatnot. Although that was trained on Llama as well. But I would think, like, obviously the direction they're heading here is like agents and embodied robotics, and I believe we're all quite aligned on what we're doing, not only technically but in our like open ethos about all of this, which is like particularly important for our application space, right? Okay, yes, this is very good information to have. But yeah, it's funny because this is almost, they do it almost more like that very first demo that I did with, it was when Llama 3 had just came out, and I did this like little function calling demo with it. Even though it didn't really have that built in, this one, okay. I'm not going to play the video. I just like want to refer as to like what it is. But this one, you can see the function calling is like in line with the bot output, and it's done with a much more Python-like syntax, where it's like actually writing the Python code for the function as opposed to the JSON interpretation of it. And maybe they did that because it takes up less tokens and it's more concise, and which was one of the criticisms I had of the much longer JSONic way of doing this. But then on the flip side, like this was much less reliable, and it was not tuned for it at that time. But it is here, and that kind of serves the basis for the initial docs around this, which are still up here in this section. Yes. So this, I would call this like version 1 of the function calling that I had implemented which, funny enough, it would seem like the Llama models might still be more aligned to that. And this way is done in line with the generation. It does not need to do multiple generations because it can just like tag those Python functions as they come in, as opposed to being templated to wait and do multiple responses. Because in these cloud systems, it's assumed that like when a tool is called, it has to go back to the client, tell what tool it was, they run the tool and give you the response back. Whereas if you have the knowledge of knowing you're all on one system, you can do all of that inside the same request and reduce the latency, which is probably what they're getting at here. And as we saw on the build demo, like those latencies end up mattering. Okay, this is interesting. Let's see if we can find where it talks about the 8B thing.
Yeah, I mean, this has been very interesting to me to follow. I actually haven't tried to implement it myself yet, but you know,
Okay.
when you're having wearable technology that you're trying to communicate with real time, having it understand what you're asking it and to call functions rather than what I'm doing now, which is an intercepted command language.
Yes, and to that effect, I think what differentiates the tool calling or like tools from just constrained JSON output is that generally like the tools at least have the capability to like run again. Okay, hence the term tool, that like it uses to get your response from it, as opposed to like the JSON output. It just outputs that constrained JSON to you, and then it's done. And both are, you can survive either or. But in general, for like the text LLM side of things, this like controller LLM, it would seem like one of those two is now like an essential feature for us pretty much. And fortunately, we got in early with like these Minitron guys and have these features in the 4B mini version of this too. So that's like my overall grand vision is like, oh, on over Nano, we have the 4B Minitron alongside the VLA 3B mini VLM and Piper TTS and Whisper ASR, and ideally be able to fit all of that. I think maybe the mini VLM is a bridge too far for it all. You'll probably be able to do the mini VLM or the 4B and ASR TTS, or like some combination thereof. On an 8 GB board, it might still be hard to do that. Okay, well, without belaboring this, again, it is always, you know, exciting to be part of this like developer movement, and all this new stuff comes out. It does get exhausting though, keeping up with it, because right now our focus is very much on like the vision models, and it's become a cognizant thing to me. It's like, oh, I do need to keep up with the text-only LLM side of things, more so for like the controller agent that would oversee our systems and be receiving like the event histories and all of that. So, and it does take a long time to go through and like characterize all this stuff and really get to know these models, which ultimately are what enable us to do all these like amazing capabilities that we're trying to roll out right now. Okay. So if anybody digs into this and tries it through Llama or Nano LLM or just Hugging Face, let us know. Thanks, Chris, for mentioning that about the 8B, so we're not banging our heads against the wall there. When Randy posted one in here. Oh, there's already an AWQ version. Nice. Let's see what this is. Okay, this must have been a pruned 70B AWQ. Interesting. Obtained with an A140 gigabyte. It was interesting for the OpenVLA stuff in the past week. I tried to get like an A100 or an H100 on like AWS or Azure or Google Cloud. They're like all reserved and it's hard to get them. So I just circle back to the the AGX OREN and do everything on there. Okay, let's see if this will reload here. We'll switch gears to the OpenVLA and what we've been doing on that, because much akin to like the function calling, this has the potential to be like very real, right? I think that's why everybody's into like these embodied agents and robotics and stuff. And this one has been, we've had to like approach this with rigor in order to get all like the outputs lining up and everything. And so I do have it confirmed, the accuracy numbers on both the benchmark eval data from their data set, like the pre-recorded one, and synthetic sim data, which is I'm actually also able to run on the JETSON. And I realized in the screen recordings of this later, the video is like very choppy, and I think it's because of the screen sharing. On my end, it looks smooth, like in the YouTube videos and whatnot. Yeah, so essentially what I've done is integrate this MimicGen, which comes out of the Nvidia Groot team, actually. Nuke and Jim have made this, and this is actually built on a whole stack of these other simulators that they've done in the past couple of years to like basically completely automate the whole process. So you're not having to sit there and like teleoperate the thing to collect all of the data, and it's meant for large scale synthetic data collection across, different episodes, and to be able to change the environments around, do different tasks. And interestingly, it's like built on the OpenAI Gym style interface. So it's very simple to use. You can just like pip install it. It's built on, so I think like originally the OpenAI Gym came out, and then there was this like Robo suite that was built on top of that, which took it over when OpenAI stopped maintaining it as much. And then on top of that, they built this Robo Mimic one that is able to do more generalization and add in like new environment generation and stuff like that. And then from there, they took it and built MimicGen on top, which is very interesting because how this works is first for these different, and they have like 20 different environments that they set up. And first they have someone go in and teleoperate it like 10 times. And then it like interpolates those recorded trajectories to like new positions in the world. So like moves the block around a little more, and then interpolates the teleopt trajectory to that new location, and then is able to like generate all of this new data based on that. Chris, you have a hand up there.
Yeah, are they teleoperating the simulated models, or did they do teleop on the hardware and then transfer that into embed that in the trained model somehow? Or
they do it in sim, I believe. Let me get back to their doc. Let me get back to their docs here. They have really great docs for all this. And this is like super simple to install. Obviously, I do want to use IsaacSim for this, but for like this initial workflow, basically I've been trying to get this whole workflow set up, and I've been doing the fine tuning also on JETSON. Eventually, yes, this will scale to using IsaacSim, but in the meantime, if you go into these docs here, and I had to like dig in and follow these because their pre-recorded data you can get is only like 84 by 84 pixels tall, because a lot of these guys come out of like that RL policy research where those models take in very small visual inputs. And even with OpenVLA, that's only 224 by 224. So I like really dig into all of this and regenerate the data at a larger size for OpenVLA, which was very useful, because then I learned how to just go and do all of my own scenes and stuff. Like, for example, I wish I could share you the actual demo videos, but for example, there's like, if I wanted to change the color of these blocks, or it's the block stacking one is the one I'm trying to get working right now off the bat. And like if I wanted to change the colors of the blocks or change that around, now I know how to like go into the script and like export it all. Once you figure out how to do it, it's not bad. But yes, you have to go through here and like do it all individually. So this is the step one is they give you these there's like 10 episodes on each of their environments. And I believe from reading the paper, like, yes, these were collected manually. And I forget if it's this one or not that has different quality levels for it. It might have been, okay, I think it was RoboMimic. And sorry, I'm like clicking around a lot. It was over the weekend, I like dug into this because initially I was just using this Robo Suite, which was like comes up first and is popular. But then once I dug more and more into that, I naturally followed this progression of their work to getting to like the MimicGen and being like, this is actually what I need, because it not only outputs the natural language prompts, that's very important, is like you need to have the data of like what is the robot being told to do, but also this ability to like synthetically generate new tasks, environments, and like configurations of those. Because like actually doing the teleoperation and just virtually with like one of those space nav mice is not too much fun. And yes, I believe it was this one where they have like beginner, medium, expert level.
So is Isaac Sim going to support like VR-based teleop and simulation? Or
It probably already does. And that's part of this too, is like me learning what is already in there. But I would assume so. And I know like there are actual roboticists are highly engaged, not only on that, but also like these other haptic devices that people are using. And obviously, oh yes, okay. So this is it. But that is a big thing that now I clearly understand why there's so much focus on like the teleoperation of these, very accurate, because when you're having to teleoperate them, you have to set the gold standard for what you train the robot to do. And
Right.
in this example, they do dissect it into like the good quality human, expert, and like beginner levels of this. And yeah, and here's like another project that comes off of this, which was like the RoboTurk one. And this has a huge amount of these data sets in it too, which like I've got to get into also. So like this body of work from these guys is just huge to take. And but interestingly, what just the sense that I get is the OpenVLA guys were very much like the OpenX embodiment data set, which is a TFDS format, TensorFlow data set, or RLDS, it's called. This data set format. So this is what OpenVLA uses. This is what OpenX embodiment uses. And it seemed like the OpenVLA guys mainly stuck with this for their training. Whereas this almost like other branch of research has more so been doing like the synthetic data generation, and their format is, let's see. You can actually follow what I've been up to the past couple of weeks, because I've spent an insane amount of time writing all this data set code, because I like really needed to figure out, is this model accurate or is it working, right? Yes. Whereas like all of these other guys, they use this RoboMimic format, which is an HDF5. And that's not to say like the discrepancies between TFDS and HDF5, like who cares about that really? Although like I just wrote a converter last night from this HDF5 into the TFDS so that the OpenVLA fine tuner can ingest that and basically be able to run like the simulated data through it. That's my next step with this, because while we got like 95% accuracy on the bridge data, which is like actual in person, when I ran this simulated loop through it, it dropped to like 75% accuracy. So now going back through the steps to fine tune all that, need to hook all this up. Ideally, at some point, I will have the fine tuner right here inside, like as one of these nodes. Right now, I just call it as like an external script. This one. And like this script is actually very approachable, the fine tuning one. It just uses the Hugging Face one. So I could actually like rip this out and put it into the same process, because this runs at roughly 1 frame per second. And I had previously proven this to work just by feeding in the bridge data set that it was already trained on. And it got 95% token accuracy, which like they measure their accuracy a little different at this level. They just like compare the actual output tokens to it. Whereas these other numbers that I showed earlier, this is based on like the normalized R root mean square error of the final actual values of it. So it is good, like we've confirmed on the actual bridge data, the real world data, that it gets 90% plus accuracy on that. That isn't to actually say the success ratio of these episodes. That's still what we're going after to evaluate, because it could be 98% accurate and then generate a out of distribution output that throws the whole robot off and ruins the whole episode just one time. So it's those type of things that we're going back through to study on this. But we have basically all of the workflow in place, including like the simulation, the data collection, the fine tuning and everything. I think I have some fine tuning. Let's see if I can log into this. It saves your like training runs to their cloud here. And I might actually change this to using TensorBoard, so like you don't rely on their other website. Let's see if it'll still work. I just wanted to go in and show you guys some of these fine tuning runs that I had been doing on it. I know like Nigel had been doing these too, and it confirmed that the whole thing worked end to end on like some simple stuff. So that gave me a lot of confidence, like, let's continue grinding on this. And it's just a matter of like seeing the whole thing through. Eventually we'll get to like the sim to real part and actually like deploying this. And hopefully like getting on some actual robot hardware with it. So we can see here, like this ran on the JETSON, trained it for a few thousand steps. I think it's recommended that they say in the paper that to train this on less than 100 episodes, typically the episodes have about 100 steps or frames in them each. So it's about 10,000 steps or 3.5 hours to do this, to basically port it to a new robot, which is basically, let's just say, essential for everyone. They even fine-tuned it for their eval results. Like when they went, there are a few key data sets from OpenX that are heavily weighted in their training ones, including Bridge. But then when they went to evaluate it on, I forget which one the Droid data set, I think they evaluated it on. They needed to do a fine tuning just to eval it, okay? And so that means like it's foregone conclusion essentially that you will need to fine tune this. Hence, we will make it as easy as possible for folks to do and have that highly integrated into the whole workflow, which I think will bode well for us just in general in terms of like our abilities as individuals and as a group to take this on and do this. But yeah, it says like they did it for less than 100 episodes, and then were able to get an upwards of 90% success ratio on like their actual in-person physical robot. So I do believe that bodes well. And mainly this was just to see like, how does it run? Does it work good? It runs so good, in fact, that now I'm like, I want to scale this up to all the JETSONs that I have and do like the fully sharded data parallel, FSDP mode, where then I can do like the full fine tuning on multiple JETSONs here. Because it turns out that AGX R164 is like actually great value, and you can get it. Chris, you had a question?
Yeah, so I just noted like in their data set for the tasks that they trained on, a lot of them are like variations on pick and place. And there's some like cable routing and things like that. So I'm wondering, how do you anticipate, Isaacson being able to do like facilitate more complicated tasks that have collisions?
It's a great question. Here's what I think. And I think from like, you understand, like, yes, like we like to be like play around with robots, and I do not consider myself like a PhD roboticist. They do actually like are working on that, and I think what they're doing is like have another LLM Llama go through and synthetically generate the code that makes the environments. And
interesting.
I mean that's what I would do, right? Because they have. I encourage everybody to go through and like dig through, and this is great because it is simulated. You can pip install on JETSON. Basically, I'll have it in the containers and everything, but it like runs at 20, 30 FPS alongside everything. It can be the one-stop shop on the device. And I'll talk a minute about using like the Z and this Z-Foo. I don't know if Walter's on today, but like we're going to use that to scan the environment and then simulate it. But essentially, to add new environments to this, you go through here and set up new things. So they start off with this base environment, and then they have other ones built on top that add complexity, like multiple blocks, or the randomness is more, things like that. And this is where it actually checks for like the poses and that the criteria of the task are being met, like the blocks are in contact with each other, and then it gets like a reward for that, and or it got a successful episode from it. So yes, somebody did go in and for the cable routing, this is all manually coded, but then it can do randomness on certain, like where is the cable at, or where the block's at, or what color is it, and things like that. But the actual like mechanics, the flow of the task is still hard coded in. And there are interestingly ones in here that have multiple subtasks to them. And that's all important for like generating the natural language prompt of it. But there's enough of these that I would think that like you could do in context learning with like a coding Llama 405B or a Nemotron 430B or whatnot, and generate lots more of these environments. And I think like that, I'm sure I don't even want to like try it because you can probably spend your whole research avenue just on that. Like I'm sure they're doing. But yes, in the longer term, I would think that would be essential. As like Isaacson already has great SDG for like textures and all of that other stuff. But in terms of like the actual scenarios, that's important. And that's very important for like the foundational model thing. If you just want it for your own particular one, I think it's a different ballgame, because kind of remember with the JetBot, right? That you only had to get like 100 annotations and then it worked great in your own room. If you're trying to do a foundational model that generalizes to lots of different things, yeah, you need to do lots of different things. But what if we could utilize like this? The Z has this really nice Z ZFU spatial mapping module that's accessible both in their tools and via the Python API. See if this is onto what I wanted to find with it. But like we could use this to scan the environment, put it in that simulator, and then it's able to simulate itself like in your room or whatever space that you want it in. And this is kind of what I will want to work on next. Once I get to like the sim to real part. The results look, I was hoping Walter would be here today so we could chat about like how this actually works in practice. And because this isn't full on SLAM, this doesn't do the localization part, but the mapping looks really good. Because I look like, oh, Isaac Sim mapping, what is out there for this? And this was like one of the best solutions for it. So like put a Z on the end of the robot arm, have it scan its own environment first, and then fire up this one device simulator, and it can like start simulating its own world, which I think, and if you like read like psychology books or whatnot about like human consciousness, it's that ability to like simulate your environment and think through ahead about things that ultimately give humans a higher order of intelligence. So that type of like on-device simulator could come in really handy to do. But yeah, I anticipate like a full LoRa fine-tuning time to be on the order of like 3 hours or so with this. And hopefully by the next meeting, we'll have like the whole simulated workflow at least proven out. There was something else that I wanted to show you guys with this, but that's probably good for today. This is like probably like the top priority that I'm working on, just because of like what it represents, these embodied capabilities, and it's like all getting pretty real, right? If we have the ability to like control the robot with our voice, have it go off, do relatively complex things, then that's awesome. That said, this OpenVLA and the manipulator is like diving into the deep end on it. Although like Nigel and I have been, and some others have been going back and forth to try and get it all working, and we have some initial positive results out of it. Oh yeah, I wanted to connect it back with the VLA fine tuning, because I think what I would do next after, like assuming get the whole simulated workflow working and like fine tune one, get it in sim, get it optimized enough that like the control loop works. One thing I have to play around with is like what's the right time step value for the thing to make smooth output at 2.5 FPS, which is like slow, right, for robot manipulator control. That's like something we're gonna have to work out and see, is this maybe better as like a global planner? You know, does it need to do every single time step, or is it enough just to say, oh, next in the sequence is to go move your manipulator next to the coffee mug, and then I'll tell you how to actually grip it once you get to there, right? But from there, it's like, well, we do want to get into like ground vehicles and stuff too for ground robots. And the VLA guys recently enabled LoRa in their code for their stuff too, because they previously required like 8 A100s to fine tune. Okay, so this was not super possible for normal folks. Again, like including ourselves in that bucket, because ultimately, like we're all here together. But what I would really like to do is try to do like a basic ground robot version through VLA, applying similar techniques that kind of like combining the best of VLA with the best of VLA. I think one thing that Nigel found in his initial experiments was the spatial resolution of OpenVLA is lacking. It was not able to do very small pinpoint tasks. He was trying to have it like pick up a needle or something. And the 224 by 224 resolution was too small for it. Whereas VLA is like 384 and using higher siglet. On the other hand, VLA does not have the Dino V2 encoder in it that the OpenVLA guys said has improved spatial resolution, or like the ability to discern like where in the scene things are, because typically VLMs don't get great reputation for being good at that kind of thing. So we'll have to play around with this. There's also like the mini version of the VLA, the 3B, which is like, I want to get more optimized performance. And again, with OpenVLA, it has the concept of these special tokens, which were encoded far into its pre-training, of using those special tokens to represent coordinate space outputs instead of actual digits. So there's a real back and forth between them. And the constraints we're working with is going back and having to redo all of that pre-training on it, you know, hundreds of thousands of GPU hours. And instead, like, trying to see if we can get some positive initial result out of this just for like a JetBot, and having it output like single digit token control, like 1 digit for left, and then one digit for left, right, 1 digit for back, forth. And so it's like a 2 token output, kind of approximating this like notion of these special token vision models like Florence 2 and all of those. And I believe really what we would like to show is like this workflow of you training your own special vision processors, whether it's for a ground robot, a manipulator, your smart camera with function calling, or like whatever, and just having be easier and more approachable doing these LoRa's and stuff. And it's the torch distributed that I've actually FSDP, yeah. This is what will enable you to break up the model across multiple JETSONs if you need to, or parallelize it across both. Because I have like 5 AGX overns here, mainly building the GitHub containers, but I can like turn that off and use it for training. So I'm at like one image per second of OpenVLA training. Could theoretically scale it up to like 3 or something. And like, that's not too bad for doing this like fine tuning. We'll never be able to do like our own foundational models or whatnot, but setting a goal to do these fine-tuning workflows and have them like integrated into the tool naturally, so like the flow is all nice. Anybody can do it, either via teleop or scanning their environment and having it run in the simulator. Also, ideally on board if you don't have access to Isaac Sim in the cloud or on a more powerful desktop workstation. And just like really figuring out that whole flow and hammering it home so that like anybody can go do it. And then voila, you should have your robot that you can speak to in natural language and teach new tasks to interactively, which is really what we've been going for like the whole time here. Okay, so I would hope in another 2 weeks we can show like the whole thing working practically, and I've been getting really close. I was hoping to show it today. It's just like, yeah, spent all last night on like some data set converter from RLDS to TFDS, and like these things, like the data sets are so large, the models are so big, it just takes a while to, when every training run takes 5 minutes just to load, you know, it takes a while to iterate. Okay, well, obviously we, you know, had a lot to dig into already. Jambo, I believe he was on the call earlier. I'm not sure if he's still here or not. This is a great new development too. He very so kindly got Phi3 Vision, which was one of those not well supported VLM in the quantization tools. Looks like somebody had their hand up if they wanted to ask a question.
Hey, hi, Justin.
Hello.
Yeah. So, by any chance, like, I've been listening to you for past hour. By any chance, do you have any kind of a documentation? Even we were, if you remember from the last session, even we were doing the similar talk about the implementing OpenVLA on like real robot. So from the MimicGen and stuff, have you happened to have any kind of a documentation just to like verify?
I have not yet, and I will. I will make an awesome page on the JETSON AI Lab that lays this out step by step. And once I get it working in the sim, I will take a few days and do that, so that you guys can go get caught back up with that. Once I get like the fine-tuned model working in the sim and can show you like doing like basic stuff with it, then that will enable you guys to go off and either like teleoperate it yourself and collect more data, or tweak the MimicGen source to make new environments. But
Sweet.
yeah, and like you can, I have been like checking in my code for this. At least I've not been like rebuilding the containers constantly or really documenting the whole thing, just because like we're still grinding it out and figuring the whole thing. Although I would say like we're pretty confident at this point that the whole thing will work. Nigel and others have gotten initial results that at least show it's like feasible. On my end, and mainly like performance focused, like it's 2.5 FPS enough. Is the whole workflow smooth enough that like normal people can do it? But yes, what I would recommend is like kind of like start where I did and just dig into all of these, and you can feel free to go in here and look at like all these different data sets that I've added to it. The actual support for this, like there are examples that you can go run now if you can figure out how to like get the data. A lot of those data set loaders that I just showed you will automatically download the data for you, but all of this code is like already in here and you can see how it is. And like we painstakingly made sure all of like the action space normalization is right and like it's working in the right coordinate spaces and like all of that stuff, which is why we like go back and do all of this like data set validation and all of that, so that when it's not working, you can pinpoint where in the pipeline it's broken. Otherwise, it's like a needle in the haystack and you're never going to figure it out. Okay.
Perfect. Thank you.
Yeah. And please, in the next couple of weeks, if you're working on this, feel free to like hit me up, and love to collaborate on these things.
I think we had like a meeting, if you remember.
Yeah. How have you guys had any progress since then, or hooked it up in your simulator or things?
So we did happen to go through like the prismatic VLA and stuff. We have not come up with like some solid results, but we are collecting like the more on data generation part, like curating the data and simulating it with the RFs. Okay.
And had you found, as I recall, like you probably have desktop systems, so you could just run IsaacSim. If you have an RTX card, yes, I would recommend just start on IsaacSim today. Although like I do feel that this MimicGen and that Robo suite, which is essentially like the OpenAI plus Majoko backend, it does use GPU for OpenGL, but only like less than 10% of the GPU. Having that onboard simulator, I feel like in the future that is going to be like a valuable thing for us to have access to, and it does make this whole thing turnkey for folks who want to get started. Sorry, there was another question. Somebody else has their hand up. Sorry if I missed you earlier. Kumar.
Hey, Dustin.
Hi, how are you?
Hello.
Hi, yes, we can hear you.
Okay. So we have been trying to use Florence to model specifically for OCR tasks. Okay. And it is the only smaller model that is equivalent to Google's Polygon. Okay. And is there a way to train this model specifically for OCR tasks alone?
Well, I'm sure there are. And like OCR was, you know, like there were models just for OCR, and like the Florence stuff is really good at OCR. And I think more so like the VLMs keep being like the VLMs they train just for captioning essentially, and because like that is their foundation, okay, and just captioning. But there is a lot of OCR in that, so they are essentially like captioning plus OCR models. Florence, I believe you can enable just OCR mode in. So yes, there are, and this whole concept of having like these special modes or these one-off special vision processors that like anybody can train to do like their task. I think
they have given us custom template, like we can use the OCR token for training OCR alone, but actually no one has tried it.
Yeah, if you can go off and try it and like
Mm.
let us know. We learned so much just from doing all of this, even from digging into every detail about OpenVLA the past week. Now we have all these ideas about like, oh, going forward on next model, this like I would try these different things first on it, and I hope that once we get like these initial results and a nice tutorial page, then yeah, we can go back to the actual OpenVLA guys and be like, hey, look what we made with your stuff. Can we like be part of your little group? You know, and hopefully have some input into like next versions or whatnot of things we want to see in the future, which is the model that I've had with like the Vela guys and these Nemotron guys. And because they're also motivated to, they want to see their stuff used, and like robotics and edge are super cool and everything that we've been doing. So we do get like traction with those model trainers and are now learning to do like the fine tunes ourselves. We're not getting into like the foundational model that like way above our resources, but being able to spin up small instances to do the fine tuning and more is good. Okay. Sorry, we've become long-winded, but like there's always so much to cover in all these, and you guys are great.
Last thing, I have to ask one more thing.
Yeah.
Since the model is very large, is it possible to run it in JETSON Nano?
The original
we tried
Nano,
to convert the model into a ONNX file, and then we tried to convert it into Angel file, but there isn't much proper documentation to convert it into a ONNX file. But we can use it using a transformer JS library, but our guys are not good with JavaScript.
are you talking about the original Nano 4 GB or the Orin Nano 8 GB?
We have both, but we want to try and see if we can run it in the 4 gig one.
Okay, so there are somebody on the forum. They got Llama and Llama C++ to work on Nano 1 Jetpack 4. So, but that's like the only route. I seriously doubt that Onyx runtime notoriously drops support for. If you're not on latest TensorRT and CUDA, you are not building Onyx runtime 1.18. Okay, which like this would all be built. So you need like the latest stuff. And yes, this would run on Orin Nano and NX, but I seriously doubt the original one. And even if it did, it would be like glacially slow, unfortunately.
Actually, we are already learning some ultralight models in Orin Nano, but sorry, not in Orin Nano, the original Nano. But even those, even if we use some 2 or 3 streams, it will still lag a lot. Like we'll be getting only 0.5 FPS or something like that. We can't even do the normal face detection task in this.
Okay, if I'm following you correctly, it was about the ability to like do multiple tasks and perhaps losing the previous.
We are trying to process multiple streams at once, and also, and the other thing with Florence is we want to run batch inferences.
Oh, okay. Well, the Florence we've not completely optimized yet, and it's just through transformers and does the batching and everything fine. I think what you find is on JETSON, you will see diminishing returns on batching because the GPU is already 100% utilized. Sometimes you might see like a 10% bump or whatnot. I'm not saying it's not worth it, but for the added latency, for 2x latency, you know, it's like here nor there. But with the mini VLMs running it up to like 7.5, 10 FPS, yes, like you could conceivably do batching in multiple streams on it. Kumar, did you have another question? Was your hand
There's all done.
Oh, okay. Same person. Sorry, you're like.
And actually, I don't go by my second name. Just call me Yash. Okay.
Yes. Okay. Awesome. Thank you so much. Yeah, and if you go off and train one of these, let us know, because I think as this group progresses, we are, you know, when we first dig into this, we're learning the basics, and as we learn more and more and sink more time into this, get more experience with the models, then like we just become the model tuners ourselves. I'm not going to say like the trainers, they have their own supercomputers to do all this on, and this is just like we did with the original Nano and the JetBot and onboard. Like we have PyTorch training tutorials for the original Nano that even ran on Nano 2 GB for doing like train your own object detector on JETSON Nano, because highlighting that whole end-to-end workflow for people was like essential. And ultimately, it was at that point where you made your own model that it really like became yours, you know, and you need to take that level of ownership over your like AI workflow to actually make it like work for you. And initially when Gen AI came out, it was like, we're never gonna have to train anything ever again. Turns out like, no, you still are, but fortunately, like the fine tuning isn't that bad and can generalize to a lot more because of the natural language. Okay, just very, very quickly, we're not going to dig into all specifics of 5.3 vision because it's already been out. I more so wanted to highlight this deployment workflow as being a little different. Sorry, there's somebody, let me find who this is. I think somebody has their mic unmuted here. Here we go. Okay, sorry about that. So when a year ago, when I first started looking how to deploy LLMs on JETSON, I was like, oh, my favorite's Onyx. Can Onyx runtime do this? There was this Hugging Face Optimum library that like they had made for BERT through Onyx. Because when BERT came out in 2017 and Xavier NX, this is how we were doing it. But it bombed hard on it and never really seemed to catch up, which is unfortunately like I really feel like the Onyx guys should have like really been on that, because Onyx was supposed to be like the interoperable format. And like in the absence of that, now you see like 18 different quantization formats, all with their own LLM API. Whereas like if it would have just been day one Onyx available for LLMs, we would be having a different story right now in terms of like everything we need to support, right? But it would seem like, yeah, I guess it makes sense that Phi 3 works with this because that's a Microsoft model and they make Onyx runtime. Again, like I would love to spend a week or two really digging in on this in lieu of like OpenVLA and fine-tuning VLA, probably not in the immediate term, but I do really appreciate Jumbo like making this article, and it's really great to see others in the community like getting new models to run on JETSON in an optimized, quantized way that's like portable, has the containers, like that's really super valuable for everybody in the community. So thank you. And I've been chatting with him through this site actually, and we'll mirror this page in like the JETSON AI lab, and you know, encourage all their great contributions and everything. Okay, and hopefully in the future Onyx does get figured out and it's just like makes this way easier. You should just be able to like use Onyx for everything, as was their original like mission statement, right? It seems like we're still not there, but hopefully in the future. All right, Gary, I'm sorry I took up an hour and 10 minutes. As per usual, dude. The floor is yours. Please take it away. I will stop sharing now. Ben, thank you to everybody else who is still on. I would think this doesn't bore people out of their minds considering like everything that we got going on. But yeah, it seems like every week it ends up like this.
You guys see my screen okay?
Yes.
So nice to meet you, Kirishi, one of the founders of Gen AI Nerds. We're just so amazed by what this community is building, your guys' community, our community for generative AI. We're inspired to really let the broader array of technical people integrate these superpowers into systems. So we built an integration engine for generative AI. So less kind of agent studio and more like once you have a genie in a bottle, some magic model or some capability, how do you connect that into real world systems? So excited to show you what it can do. I hope this microphone situation let's do this.
Well, it looks nice, man.
I have a meeting with Jane.
Got it. I've messaged Jane. 1 second, please.
Wow.
They said, be right there.
I have a package. So the idea was to allow open-ended workflows to be defined, and then be able to just have a whole array of things that are like real-world business. So just because it's running embedded, which is our total story, doesn't mean it's not connected to real things. Other things that might even be in the cloud. It's just we love the privacy and the inference that happens on a JETSON. Why that can't be connected to the rest of the things that drive a business.
Most JETSONs will be like edge to cloud, and like thank you for seeing this through like the whole way. And I love how it shows like the progression through the agent pipeline. It's super snappy. Well done to you guys.
Thank you very much. And then we have these shipped Docker containers. We hope to wrap more and more of yours, Dusty. But we invite you to, there's a publicly hosted one that you can play with now in terms of both a server and then the Docker Gappy backend can be fully run on your own JETSON. So completely private off-grid in terms of where these workflows run. And the cool thing is it offers sort of unified plumbing. So it does binary plus JSON messaging. So I can download a Gappy, Whisper node, and I'm running it. That demo I just showed you was on an Orin Nano 4 gig.
For real? Nice.
Yeah. So we have Gappy.
And I love how it connected on the back end too. Like after you tested it back in Slack, it connected back into like the whole thing. And yeah.
Yeah. So the cool part about so some of the integrations we have. So if you saw this when I slacked back. It actually can receive messages and then just drive it through. So when I said I had a meeting with Jane, it's driving through speech to text and then a vector query, and then it tells the app, which was the simple JavaScript code on the left, acknowledges the person via text to speech, and then messages presumably an employee, which I just set up like a channel on my Slack. So if you start really thinking about the power of generative AI, but then putting them into pipelines, so like we have a whole, and mind you, everyone on this call is perfectly capable of doing these things themselves, but for like a lot of other people, the idea that I can use these superpowers, but do it with like great ease in terms of being able to integrate them into pipelines. But I would encourage you guys, if you want to try it, because you can download your own, it's basically just this amount of code. So there's 4 Python files. So if I have a workflow and I add, let's see, a microservice, and then I pick my microservice. Okay. And then I have this code, which when the pipeline gets called, this gets called. So then you're dealing with your request JSON object and potentially binary data, and then you respond. So if I go into here and boot this up, you'll notice it's just a simple Python file, which then tells me that my microservice is online. So just grab a key, fire away. When you go into the workflow, I hit enable. If I hit test, you'll see that it just sent me the code from here. So if I said running state 10, try it again, you'll see. So it's giving your code, whatever genie in the bottle we all have, like some model or something we haven't integrated, the idea that you can then go in and say debug. So it's let's go like this. So then you can do expression. So you can say like running state, current state equals running. And so you notice the input, the rolling input of that transaction from the left-hand side comes in, and then you just percolate data as it goes. So,
and you're just like indexing JSON dictionaries in there through your templating.
yes,
And
so the cool thing is that any node throughout the pipeline is appending JSON bodies into this total transaction. When you go to dereference it in there, it collapses it into one super map in sort of a last in first.
That's really smart. Then it all stays synchronized with each other.
Totally. So then there's a concept of a transaction. So like if I just hit test, right? So you'll notice it drove through the workflow, and then this guy's got each of the node steps of what happened. So I can actually alter. So it kind of helps you to say, oh yeah, current state running.
Yeah.
So it's the first version. We've actually put it in production for a couple of customers, but we open it up for free. It's open source. It's all the stuff.
Awesome.
But also it gets so fun when you think about it. When you create an account, all these tips are in here, and there's just like these little micro-sized things. So you can actually like send emails, and like we actually put a Twilio key in there. So like my phone's in the other room, but but you can imagine a world where you're like texting with your JETSON or like slacking with it. It starts to get super.
It is great. Yeah. Well, and again, like we're always just using like the alert button is like your proxy for it, and like I don't have the time to. It is very nice. You've gone off and done like the real world stuff, business logic, and can be set up for edge to cloud. They're like the JETSON platform services can be integrated into this with all of their like Redis and actual like production databases and all stuff for like actual.
Yeah, well, you and I were talking about we're adding some new components, which would be like a GStreamer component. So if it's all local, you could start pulling in our TSP streams and feed it to VLMs. My daughter just brought me over to show that she got a text, which was the text.
That is so cute. Yeah.
Text from Twilio. And I see that someone asked N8N. We actually started building it with N8N and didn't like the implication of the open source thing was like a little heavy. So we actually used the same widget library as them and just built it all from scratch. So the cool thing is,
what library are you using?
So it is Go.js, which is the library. We're going to eat the couple $1,000s to get this watermark to go away. But basically,
I guess that's why I probably didn't bite on that one myself.
Yeah, I mean, it's a phenomenal library. So, but Gappy, the server, is going to be available as a Docker download. The GenAI Gappy.com, go in here. It doesn't even send you an email. Just plug it in, you blast right in, and you're rocking and rolling. Okay. And then we clone these tips, these microservices, and a whole bunch of goodness. So,
okay. Yeah, no, and I appreciate that like you support all these different services. The services are just like some of the containers off of JETSON containers and like NGC, other ones. So you can like really bring any of your own code of the JETSON platform services into this and use it as like the orchestration tool behind that. And so like on one hand, I went through a similar thing as you, where it's like, oh, I need a very responsive web app with like full audio, video capabilities, and just start like ripping things out. So I'm like, on my end, I have like the silky smooth WebRTC and like my God, because I was going for that back and forth speaking with Llama 70B, is what I initially made that for. But
well,
the other thing together, like I'm always geared for like the real-time multimedia side of things, because in my mind, that's like we could architect the whole site to be really nice and then have to redo the whole thing when you get to that point.
If you're like me, I like the integration of the goodness more than the AI scientist stuff. I just wasn't raised on what I like a lot of the people that are on here. But so there's, as an example, like on
the JavaScript looks good, not a spaghetti noodle mess.
So no Angular, no anything. It's just like.
That's good. I'm a vanilla JS guy myself.
Well, the idea is that that through these demos you could have your own clients. So I can browse, like on GenAI Gappy, it actually serves these clients. So if you go into like if you go into here and you hit open speech client, so it'll bind all the keys, all the yada yada. So you can pull it up on your phone and go run around with the camera and pipe images into your VLM. So our idea was more like, how do you have it integrated to a lot of things to show your boss, or for, we're all working for businesses, right? So like, how do you get all that stuff connected,
like
easier?
The NIMs and everything. Cool.
So we do hope to inspire like more integrated Docker clients and components. So like, this is my content information. So send me a message, and we'd love to work with you guys to extend this.
Yeah, thank you so much, Carrie. And we absolutely should and will. Let's continue taking like the best of both of what we got. Because like where I am is, yes, like I build out like the agent studio thing. It is very fun to go in and like it helps my rapid development. It is part of like when I'm doing the OpenVLA stuff. I need all of that right there so I can that I can do it. That said, like I do not have, I can get things to about 90% and like that's it. I gotta go on to the next thing. And sometimes it's very hard to predict what that is. For example, anything that's not these VLMs or VLAs or these other vision processors right now, that's literally the only thing in the world that I'm like focused on other than like my kids, right? Just because it's the capabilities it represents. So I don't have.
We really want to make this glue easier, so we can basically take a Docker, and so like if you take this bin data, that's like a JPEG or video stream from one of our sample client interfaces. So we just took all the plumbing out, and it's SSL, it's WebSocket, so there's completely no latency, and then like you're responding with either this or JSON or binary, and so all the plumbing is handled.
And I feel like this could run on x86. I mean, you probably do, right? You can have the x86 version of this for people.
Yeah, both the server and the microservices can run everywhere.
Okay,
So the last funny note, I don't know if you guys knew this, but I first met Dusty. I interviewed him on our channel, and it went like pretty viral. Like,
I remember. Our marketing PR guys love that one. Signing things to come, you know.
Yeah, it went kind of viral, which is fun. So we appreciate all the stuff you do, Dusty, for the community.
Well, like what you've always been like super down to earth guy, just ready to jump in, hacking on this, and that's what we're gonna keep on doing. I would think in the broader term, like what do you need for these? Because there are several of these like GUI tools now, and that is really just like the end for you. You have the whole orchestration system on top. I'm just thinking like, how do we get that in front of more people, like beyond just JETSON? I'm comfortable with all of my stuff, like basically just I don't have time to do anything other than latest ORIN and get it to run because I want those physical capabilities. But for everybody else, like the long-term broader adoption of like your work and its success, how do we all work together in the community to get that in front of more people? Or like, what is like, I know the open web UI have been doing stuff too.
Let's have a breakout conversation about, because I think this is on GitHub. I think that the public version, even though I think a lot of people want to download it privately, which is cool. We're like 2 weeks away from that, but I think I think for a lot of people, I think, let's say Raspberry Pi was so successful because it was easy and approachable, and I think generative AI is not that at all right now. So
it both is and isn't, like, because it is from your phone, ChatGPT, it is, but the reality is the models are huge compared to what we were just working with a few years ago. And even though there's a Llama and other things that it is like relatively easy when it works, right? I
think it's all being forced on us in terms of how we use it. But if you're a technocrat, a maker, an IT lady, someone who's like, I bought this and I want to do it, then it's like kind of not approachable at all. So
that's the gap. I think on one end you see like, oh, it's forced on me and pre-prescribed how I need to do this. And then on the other end, oh my Lord, what do I need to do? It took Dusty a year to do that stack, right? That if it feels pre-prescribed, like just use my Docker images, please save yourself.
Your Docker
Okay.
stuff is like, yeah.
Like,
so-
okay, no, fine. I encourage people like they don't like Docker. It's like, I get it. I used to not like Docker either. Cool. Go off for a few weeks, cut your teeth, grind it out, come on back. They all come back and I'm like, I get it now, dude. And yeah. And I wish we could like support every way. The ways that I do end up using are the optimized ones and through painstaking benchmarking and stuff like that. And at the end of the day, our role here is to support I'm speaking of like the JETSON dev techs and such like myself. Our role is to support the broader community in whatever tooling they want to use. If you want to use Llama C++ and Llama and run it at 20 tokens a second because it's easy, great. Like we're just happy that you're going out and trying it. If you want the optimized perf, we have that too.
I would posit that we're getting flooded on the YouTube channel hit like 500,000 subscribers, and then the website gets a lot of requests, and none of them are people that are like on this. They're non-AI experts, and they're like, I want to use this. Like I did the face project 7 years ago, and now I'm expired to and it's like, cool, let's let the rest of the world see and play with these superpowers.
Yeah, and the gap is wider. The technical knowledge gap about it is wider than I even like anticipated in my head it being. Like these people, they don't know what Docker is or Linux people at all. You don't have to be some PhD machine learning LLM researcher, but yeah, you do. We're still at the point where you got to get in and like cut your teeth on this stuff, and you will be rewarded.
We all need our we're willing to eat a little bit of vegetables, but you do need the dessert to get started.
Yeah, no doubt.
Well, I mean, you like doing it over the
yeah.
You like
I
doing
try
it
to
over
make
the
it fun for
weekend.
people, but
So I think that's our goal as a community, and then like as an experience. So if your team wants to like explore how to like put that in front of more people, of course.
Totally. Yeah, you do need the carrot at the end of the stick there. I feel like we've been doing well from like a technology demonstration perspective. Like, yes, you can talk to Llama 7B, 70B, 8B, whatever, with ASR TTS, have an interactive conversation. We have the live streaming VLM. We're getting into the VLA, all that stuff. Now what people are shifting to is how approachable is it for like normal folks, and coupled with, is it real? What do I actually use it for? In like, I feel like the robotics stuff and like the vision systems are the best thing. Like, it's obviously more than just like a chatbot, you know.
We're also about a week away, so the Gen AI Nerds community is gonna do a Gen AI bot. I think it's gonna be genaibot.org, and it's the Jet bot with speaker, microphone, talk to your robot, runs in a wallet, swears in French, right? It's like super fun generative AI version.
Yeah.
Generative AI version of it. So yeah, we're
okay.
We're loving it all.
What kind of models do you have running on that? And again, like the original JetBot, just like an integrated PyTorch classification, ResNet 18 essentially is great for just showing like the AI. Even my 7-year-old daughters, they understand how machine learning and robotics works because of that. And you don't always need the latest thing, but in order for it to follow your natural language instructions, that is the key piece.
The goal is up here, but I mean, just since I've met you, right, it would be ludicrous to think anything but AGX. Now you're like NX16. I know you pushed me to go to Orin Nano 8 gigs, which I would love, but it's another $100 for our community, which $100 is $100.
Yeah.
So on 4 gig, as an example, we've got Whisper, Piper TTS, Llama, Tiny LLM, all running just with like I don't know, 100 megs of RAM.
20 megs. That's great, and that's the level of care and optimization that I really appreciate out of like this community. We are essentially the only ones that will really put in all that extra elbow grease to optimize every megabyte, every token per second, because like we love this stuff, and the Ultralytics guys made a page for JETSON AI Lab this week for YOLO V8 through TensorRT. YOLO is still and will probably always be the most popular model on JETSON because that's what like people are doing. So yeah, get an over now.
People are vastly sorry. I think people are more like vastly more inspired by speech text speech, large language model, RAG stuff. I mean, once you're like, oh, that's possible now, then you're inspired. Because I think I detected a dog, 5 dogs in this thing. There's only so much you can latch that to something specifically interesting.
Yeah. A lot of it comes down to like event detection and persistent systems and like, what do I need? Like, oh, the fox is in the hen house again. I need to watch my chickens and just like think of like practical things like that for real people so they don't become disillusioned by AI. And we have all these great, like your containers run locally. You can sever connection to the internet if you want to. But also edge to cloud integration is pretty nice if it's your own private cloud. So
it's just realistic.
Yeah. Okay. That's great. As usual, Carrie, I appreciate all of your efforts and like the role you guys have slid into to take this from being like a open community effort. We're all here just trying to like keep up with things, and somebody does need to go back over things while we're just like forging ahead. And hopefully once we get like the actual real cognizant robot, we can go back and iron things out. We will continually incur engineering debt from just like having to press on and press forward. So, and the stack just keeps growing and getting bigger in size. But hopefully by 2 weeks from now, we'll be showing like OpenVLA training, running, full workflow working, one of the first like embodied agents that we will have done, and then we're off to the races from there. It's still like just the beginning of all this, which is really wild to think. But all right, I will let you guys go. Thank you so much as usual. If there are any concerns in the meantime, feel free to like hit me up. Otherwise, we will meet again on August 6th. I can't believe we're just like cruising through the summer here already. It is nice when I go to post the recordings, I would like click through some of the old meetings that we've had, and having those recordings is nice because you can really see the progression occurring. Yes, it is like slow and steady. 3-4 months feels slow in today's like warp speed AI world. It's really not. We've made a lot of advances here in a short time, but like just like everybody continuing to work on this and really like dedicate themselves and all the resources they have available has been really great to be a part of. So thank you, everyone. Thanks for joining us today and staying on late as usual. We'll see you guys in another 2 weeks on the 6th. Until then, have a great afternoon. Thank you, Carrie, so much.
Thanks, guys.
See ya.